In this video, let us solve more problems based on properties relating to areas of similar triangles. And we've got a question here which reads this way. Prove that the area of the equilateral triangle described on the side of a square is half the area of the equilateral triangle described on its diagonal. Well, here's the diagram. It says that the area of the equilateral triangle described on the side of the square. So this is the equilateral triangle, that is BCE is the equilateral triangle described on the side of a square. And then we've got an equilateral triangle described on its diagonal. So here is the diagonal AC, and then we've got an equilateral triangle described on its diagonal, right? So now we have to prove that the area of the equilateral triangle described on the side of the square, this triangle, that is CBE, is half of the equilateral triangle that is described on the diagonal of the square. So we need to prove that CBE is half of AFC. So let's see how do we go about proving that. So now, since it is told that the triangles BCE and AFC are equilateral, they are also equiangular, right? So triangle BCE and triangle AFC are equilateral, which is given. So therefore, triangles BCE and AFC are equiangular. So if you recall a little bit, two triangles that are said to be equiangular are similar to each other. So therefore, we've got triangle BCE similar to triangle AFC. So now if two triangles are similar, we just did a property that said the ratio of the area of those two triangles, that is the ratio of the area of triangle BCE over area of triangle AFC will be equal to the ratio of the square of the two corresponding sides. So let's take those two sides, BC squared and AC squared. Of triangle BC, let's take BC squared, and of the triangle AFC, let's take AC squared. Corresponding sides is very important. You can't take BC and then you can't take FC. So it has to be corresponding sides. So BC square by AC square. So now another important property that you have to know here is, now ABCD is a square, right? So therefore the diagonal of a square is what? Diagonal of a square is nothing but root 2 multiplied by its side. So let me show that. Diagonal of a square is equal to root 2 into side. So in this case, we've got BC square here, right? So AC is the diagonal here. So let us write AC equals root 2 into one of its side. Let's take BC. So what we'll do now is replace AC square by root 2 BC the whole square, which is BC square by root 2 square is 2 and BC square is BC square. So BC square gets cancelled. We get 1 by 2. So this is equal to what? It is equal to area of the triangle BCE by area of triangle AFC. So what it says is we need to prove that the area of the equilateral triangle described on the side is half the area of the equilateral triangle described on its diagonal. So here it is. Area of triangle BCE by area of triangle AFC is exactly half, which means, let me show here. Area of triangle BCE by area of triangle AFC equals half. So we need to show that area of triangle BC is half of the area of the triangle AFC. So area of triangle BCE is half of, let's take it to the other side. So it obviously comes on top. So it is equal to area of triangle AFC, and hence proved. So we proved that the area of the triangle BC, that lies on the side of the square, is equal to half the area of the triangle AFC, which is described on the diagonal of the square. So this concludes this problem. A pretty simple one. What we have to mainly concentrate on this problem is the usage of the property that we've been studying. So it's all about applying the properties that we've studied. So as long as we apply the right properties in the right places, the problems are going to be really easy. So let us quickly solve another problem in this video. So we've got another question which reads like this. In the figure shown here, ABCD is a trapezium in which AB is parallel to DC. That's the property of a trapezium. And AB is 2 times DC, or DC is half of AB. Determine the ratio of the areas of the triangle AOB and triangle COD. So now, in triangle AOB and triangle COD, we have angle AOB equal to angle COD. Now that is because COD is equal to angle AOB. That's because they're vertically opposite angles. Vertically opposite angles. And then we also have angle OAB equal to angle OCD because alternate angles. Angle OAB equal to angle OCD. This is alternate angles because AB is parallel to DC. Now why I'm doing this, you'll know shortly. So now what we first have to establish, okay, let me first brief you before I go and solve the problem. Now we are talking about the ratios of the areas of the triangle AOB and COD. So if you want to talk anything about the ratios and stuff, you need to first establish that any two given triangles are similar to each other. Because only when the two triangles are similar to each other can we use the properties that we've studied. Say things like if two triangles are similar, if the areas of the two triangles are similar, then only then can we use the properties like, the ratios of the areas of two similar triangles is equal to the ratios of the squares of the any two corresponding sides. So to do all those things, we first have to establish that the two triangles that we're talking about, that is triangle AOB and triangle COD, are similar to each other. So that's what we're doing here. We've established that two angles in those two triangles are equal to each other. So the third angle will definitely be equal to each other. So therefore, we've got triangle AOB similar to triangle COD by the angle-angle similarity criterion. So now we can say that area of triangle AOB by area of triangle COD equals AB square by DC square. Why are we taking those particular sides? Because those are the sides that's involved, AB and DC. So now, also given is AB is 2 times DC, very clearly given. So let's write here 2DC the whole square by DC square. Now this is going to become 4DC square by DC square, and DC square gets cancelled. So what we have to do is determine the ratio of the areas of the triangle AOB and triangle COD. So therefore we have the ratio of the area of triangle AOB to the area of triangle COD equal to 4 by 1. That is nothing but area of triangle AOB equals 4 times area of triangle COD. Or in simple words, the ratio of the areas of the triangle AOB and triangle COD is 4:1. So this concludes this problem and this video as well. I'll see you in the forthcoming videos with a new topic.